Teak 11B fits with our exponential unit, which is all our 9 teaks, but also fits within the polynomial section as it's just properties of exponents. It states that students must be able to simplify numeric and algebraic expressions using the laws of exponents, including integral and rational exponents. This teak has actually got a lot of parts to it. There's about 7 rules that we go over with the students dealing with exponents, and they're expected to know all 7 and be able to use them separately and in combination. So a lot of the exponent rules are actually housed on the formula chart. We have our product of powers rule, which is where we add the exponents. Our quotient of powers rule, when we divide the bases, we subtract the exponents. Power of a power rule, when we have an exponent raised to another exponent, we multiply those exponents together. When we have a rational exponent, which means it's a fraction, all we do is rewrite it into radical form, top number going inside, bottom number going outside. And the negative exponent rule, it's not good math technique to have a negative exponent, so instead we MC hammer it, which means we move it down to the denominator and change the power to be positive. Those are all properties of exponents that we're going to use interchangeably during class. Now, we have an acronym for some of the rules. The first 3, the product powers rule, quotient of powers rule, and the power of a power rule. It's called mad spam. Okay? If we're multiplying the bases, we're going to add the exponents. If we're dividing the same bases, we're going to subtract the exponents. If we have a power raised to a power with parentheses, we're going to multiply the exponents. So mad spam helps us remember 3 of the most common exponent rules that we're going to use and what to do. Multiply, add, divide, subtract, power to a power, multiply. So if we give an example here, this first one is just asking us to add together 2 terms. But since these terms have different powers, this has a power of 2 and this has a power of 5, we actually are not going to simplify this at all, and we are just going to keep it the same. These are not like terms. I can't combine them using addition. So addition and subtraction use the same rules that we've been using for forever, where you can't combine them unless they have like terms. But if we start looking at this example, we are dividing, we're dividing the powers here. We're dividing the bases, my apologies. Which means, since the bases match, they're both x's, I'm just going to subtract their exponents. This would leave me with x to the 4th power. Now this is because if I wrote these expressions in expanded form, x to the 7th power is actually x times 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 x, 7 times. And x to the 3rd power is x times x times x. Well, if I use the property of numbers where 5 over 5 is equal to 1, x over x is equal to 1, so all of those cancel out or become 1 when we simplify, and I'm left with 4 x's, x to the 4th power. Now this power to a power rule, this is what I mean by having power raised to power. See how we have x to the 5th power raised to the 3rd power? It looks like distribution, it's not distribution, but we're going to multiply those exponents together. This would be x to the 15th power, 3 times 5. Now this is because if I have x to the 5th power happening 3 times, that's 15 x's chilling there on my paper. So it's x to the 15th power. Many of the rules follow the same ideas. Our negative exponent rule, it is good math technique to never leave your exponents negative. So to get rid of this, we're going to MC hammer it. It's called MC hammer because we're going to move and change it. Hammer time, we move it to the bottom of a fraction and we change the power to be positive. That's it. It just cleans up your work because we don't want any negative exponents. The negative exponent is currently in the denominator. You move it to the numerator and change the power. Okay, so let's see this rule here. We've got x to the 3/7 power. We've got a top number and we've got a bottom number. If I want to rewrite that in radical form, I leave the base exactly the same. The base was x a second ago. I'm going to take that top number and I'm going to write it inside. I'm going to take the bottom number with a fraction and write it as an index. Okay, the inside number stays as an exponent and the bottom number stays as an index. It's not written here like a coefficient. It's just written as an index. And we pronounce this the 7th root of x to the 3rd power. That's taking the top number inside, bottom number outside. The rule works backwards, so if I already have it inside and outside, I'd keep the base the same. And the top number would be the one that's inside. The bottom number would be the one that's outside. X to the 2/5 power. Now, the one exponent rule that is not on the formula chart because it's so easy, it's called the zero exponent property. Zero exponent property says that any number or letter to the 0 power is equal to 1. And that's it. Now, you're going to see questions like this asked. Which expression is equivalent? Well, it's equivalent because it's the same. It's just a simplified version. We're going to use the phrase simplify the following or write an equivalent expression. So they're the same, their graph should be the same, their value should be the same. They're just in a simplified form. A question from the star that might encapsulate all of these rules together is something as atrocious as this. It says, which expression is equivalent to 10q to the 5th power w to the 7th divided by 2w to the 3rd power times 4 times q to the 6th power raised to the 2nd power all over w to the negative 5th power. That's a lot. We take it piece by piece. I'm going to start by writing down my MADSPAM. And I know that if power to a power exists, I need to do that first. PEMDAS tells me to deal with exponents first. So actually the very first thing I'm going to do is multiply that 6 times 2. My next line of this equation would be, I don't know where that 4 came from, 10q to the 5th power w to the 7th times 4q to the 12th, or 2w to the q, and w to the power. At this point, it doesn't really matter what order I do the steps in. When I'm multiplying fractions, I multiply top times top and bottom times bottom. So that's what I'm going to do first. I'm just going to combine these into one fraction. Big numbers, treat them always like you've treated big numbers. That's the coefficients in the front, 4 and 10. We're multiplying those, so we multiply them. Don't change the rule for that. 4 times 10 is 40. And then I have q to the 5th power and q to the 12th power. Well, if I'm multiplying bases, I add exponents. That's where the rules change to use the exponent rules. 5 plus 12 is 17. Then I have a w. In the bottom, there's no other constant here, so it's like a 1. 2 times 1 is 2. And then I have 3 and negative 5 for my w's. This is going to be w to the negative 2 power. Moving on with the rules, I treat big numbers like I've always treated big numbers. This is just the math problem, 40 divided by 2. Well, 40 divided by 2, that is 20. Q to the 17th doesn't have anything else it can combine with because there's no other q's here. But if I notice I'm dividing the w's, MADSPAM tells me that when I divide, I'm going to subtract them. So this is going to be w to the 7 minus negative 2. 7 minus negative 2 is really like saying 7 plus 2. So this is just w to the 9th. There's nothing in my denominator, so I could put a 1 there. Or I could just write this as simply 20 q to the 17th w to the 9th power, which is answer choice B. With most of these questions, if you focused on getting the coefficients correctly, you can eliminate half the answers. If you notice, A and C had the wrong coefficient. They didn't do 10 times 4, 40 divided by 2 to make 20. Okay, take them piece by piece. This is a complicated example, but all of the rules combine together to just simplify them down. These are the same expressions, just written in different ways. Now, one thing before we leave is this is one of the most important skills you need before heading up to higher level math classes. This is one of those basic skills like solving equations. To know your exponent rules means that you're prepared to take higher level math classes where they assume you know how to interact with exponents when they're attached to letters or variables. As always, we empower, we impact, we love. We are Skeeter Nation.